Today's lesson is going to continue to work on proving triangles congruent, but after that step, we are going to take it one more further and prove parts of a triangle congruent that we did not already prove. So first of all, let's take a look at the warm-up. If we can state two different postulates that could prove ABC is congruent to CDA. Okay, well one, and I kind of did this when I was going over stuff, this would be side, angle, side. So that's one of them. But then we can also go side, side, side. And why is this side okay to mark? Because of the fact that they share a common side, the reflexive property. So we could also say by SSS. Okay. Now, if the problem wanted us to solve by AAS, okay, then we would say either angle 3 is congruent to angle 1, reason being is we have side, side, and then 3 and 1. So that's not the included side. Or we can say side, side, and then have 4 and 2 be congruent. Okay. All right. So today we're going to learn about Cpctc. It's really fun to say a bunch of times. And basically what that stands for is that corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. And this in this little bubble here is really, really important to remember that you can use Cptc after you prove the two triangles congruent. And once you do that, then any two parts of corresponding parts of a triangle you can say are congruent. But you must prove that the triangles are congruent first before you use Cpctc. Okay, so hey man, reminds me of Jamaica. If we go ahead and mark the information, so we have angle, angle, side. So we can prove this congruent by angle, angle, side. Okay, now we're going to list other pairs of angles or sides that are congruent. So once you prove that two triangles are congruent, remember that all corresponding parts are also congruent. So we can say that angle H is congruent to angle M. Okay. We can also say that segment MN is congruent to segment HY. So where did I get that from? MN, HY. And then we can also say this third side that isn't already marked is also congruent. So NA is congruent to YE. So once you prove two triangles congruent, then that means all corresponding parts are congruent. Okay. All right, let's kind of go on to the next page and let's start getting into the proofs. So as always, we start with our given. So AC is congruent to AR and angle 1 is congruent to angle 2, and that's my given. Now, givens are okay to mark on diagrams. So AC is congruent to AR, and angle 1 is congruent to angle 2. Remember that you need 3 components, and right now we only have 2 components. So is there another way that I can prove these triangles are congruent by finding that third component? Well, hopefully we recognize that we have vertical angles right here. So we can say CAL is congruent to RAL. Okay, and the reason being, vertical angles are congruent. Now do we have enough information to prove that our triangles are congruent? Well, we do. Angle, angle, side, side. Again, mark this if you need to as you read along. Angle, angle, side. So triangle CAL is congruent to triangle RAL, And the reason being is angle, angle, side. And then if we mark our reasoning, we have 1, 2, and then back to 1. Okay. But I'm not done with the problem. The problem wanted me to prove 3 is 4 congruent. But now that I proved my triangle's congruent, that means any corresponding parts are also congruent. So notice that 3 and 4 are in the same location of each triangle. Those are corresponding parts. So we can say that angle 3 is congruent to angle 4 by Cpctc. So we should not be using Cpctc before we prove the triangle's congruent. Okay, you must prove the triangle's congruent first. Cpctc comes afterwards. Okay, let's go ahead and take a look at the second example. And remember that you can always mark the given on the diagram. And given means like if something is perpendicular, you can't say it's a right angle. You have to prove that first. But if you are given congruent angles or congruent segments, you can mark that. So we have NLM, so NLM is congruent to LNO, and then we have OLN is congruent to MNL. Okay, so right now we only have 2 components, right? We have 2 pairs of congruent angles. And what we're trying to do is we're trying to prove that OL is congruent to ON. OL is congruent to MN. In order to do that, we have to first prove that the triangles are congruent. Well, our third component, if we can recognize this, is that these 2 triangles share a common side. So LN is congruent to NL by the reflexive property. Okay, now we can say that our triangles are congruent. So I'm going to mark this now that I've proved it. And so I have triangle ONL is congruent to triangle MLN. And the reason being is angle, side, angle. And then where do we get our marks from? Well, we had angles from the given, then we have our side, and then we have our other angle given. Now that I proved that the triangles are congruent, I can prove all corresponding parts are congruent. So OL is congruent to MN. By Cpctc. Again, you cannot use Cpctc before you prove the triangle's congruent. Okay, we got 2 proofs left. So again, as always, let's start with our given. So AC is congruent to BC. That's our given. Okay, and then we have ray CX bisects angle ACB. Now, I can't mark that on my diagram yet because all it says is that it bisects angle ACB. It does not say that the angles are congruent. I have to prove that. So angle 1 is congruent to angle 2 because ACB, angle 1 and angle 2. And that's the definition of an angle bisector. So 1 and 2. Now that I proved it, I can mark it. Okay. I still don't have enough information to prove these triangles congruent. I only have 2 components so far. I have segments and I have angles. But if I look at my diagram, these 2 triangles share a common side. So CX is congruent to CX by the reflexive property. Okay, now I can prove the 2 triangles congruent. So triangle ACX is congruent to triangle BCX by side angle side. And where do I get my marks from? 1, 2, and 3, right? Just follow the colors. So my one mark was here in the black, one mark was in the blue, one mark was in the red, side angle side. Okay, so some of you might be wondering, well, why did we do all that? Because I'm trying to prove that x is the midpoint of AB. So in order to prove that, and maybe take a little active note here, need to prove AX is congruent to BX. So in order to do that, I don't have enough information that allows me from the given and from the diagram to conclude that. So instead, I have to prove the triangles are congruent. Then I can say that AX is congruent to BX because of Cpctc. Now that I proved those segments are congruent, I can say that x is the midpoint of AB. And the reason being is just basically definition of a midpoint. Okay, so again, the problem wanted me to find that x is the midpoint of AB. Remember that you cannot assume anything. So yes, it might look like x is the midpoint of AB, but we have to prove that. We cannot assume that. So I need to prove the triangles are congruent. Then I can prove AX is congruent to BX by Cpctc. Therefore, x is the midpoint of AB. All right, last proof. So angle AEB is congruent to angle DEC. AE is congruent to DE. And angle A is congruent to angle D. So since all of this was given to us, I don't have to dissect anything. I'm going to go ahead and mark it on my diagram. So AEB is congruent to DEC. AE is congruent to DE. And angle A is congruent to angle D. Let's mark that with 2. Okay, so the problem here is that I am trying to prove AC is congruent to BD. So some of you might say, well, we have 3 components. We can go ahead and prove the 2 triangles congruent right away. We can't, okay, because we have to look at these triangles separately. So I have to look at this triangle and then this triangle. So I first have to prove that this angle right here, it's kind of hard to see without me pointing it out to you guys right here. This angle right here needs to fill the blue triangle and needs to fill the green triangle. And right now, we have this space in between that we haven't proved yet. Well, good thing is we have information to do that. So we're going to say angle AEC is congruent to angle DEC. Or DEB, excuse me. Okay. And the reason being, if the same angle, which is that angle in yellow, is added to congruent angles, which are marked on the diagram, then the sums are congruent. Okay, so again, let's see if this will allow me to erase all this. Ugh, makes me do it individually. Okay, so here is one triangle, and here was the other triangle, and all I had so far were that these little parts were congruent. Okay, I needed that the big part of the triangle was congruent. So let me go ahead and change this to a different color. I needed to prove that this was congruent to this. Okay. Now that I did that, I can go ahead and say that the 2 triangles are congruent. So triangle AEC is congruent to DEB. Make sure you go all the way over to the other triangle. Again, why am I doing those sides? Because I want to prove AC is congruent to BD. So I need to look at this blue triangle and this green triangle. And we proved it by angle, side, angle. And our steps to prove it were 1, 2, and 1. And then we can say that those two are congruent. So we have segment AC is congruent to segment BD by Cpctc. So do not get Cpctc happy on me, okay? Make sure that you do it after you prove the triangle's congruent. You cannot use Cpctc in the middle of the proof, okay? It's only after you prove the triangles are congruent. Then, if you're trying to prove something is congruent that you didn't already do, that's when you use Cpctc. Thanks for joining.